There we go. Okay, so welcome to the Deep Learning with Python Book Club kickoff meeting. This is using the book Deep Learning with Python third edition, which just recently came out. And unlike the previous editions, the cool thing here is the edition is completely available online, which was not the case in previous editions. So I think that's really cool. And that's what enables us to do this book club at all. So on to the business of book clubs and what they're about. If you haven't been in a book club before, which probably you have, but if you haven't, or if you're watching this online, after the fact you haven't been into a book club before, the um, the slides will be available on this website, DSLCIO/deeppy. They're not there yet. I mean, there's version of the slides, but these slides I'm going to show you about the chapter one are not up there yet. I did put the PR in, but they're not up there yet. And again, the book is at this URL, which I showed you before. And this is the code of conduct that you should review at some point. What I was trying to say before is you haven't been in a book club before. This is not like I'm not running this book club. I'm just a facilitator. My only real job is to make sure these meetings happen and to, for example, if somebody volunteers for a chapter and they don't show up, we'll still meet. And what we'll do is we'll just go through, I'll lead the discussion, or anybody could lead a discussion through the chapter anyway. We don't really need somebody to make slides like this for the chapters, but it's nice to have. Like what it says here, it's a great way to learn the material. Who's a volunteer to lead a discussion on a chapter. You'll sit there and prepare however you want to. It doesn't matter. You can just go through the notebooks for the chapter. You can make your own notebooks for the chapter. You can make slides using this GitHub repo where the slides live, whatever you want to do. The main thing is just to review the material, ask questions you had about it when you were reading it, help other people ask questions that they had when they were reading material, which they probably will have. And you can maybe do a live demo if that chapter has code in it using like Google Colab, for example, for this book. They recommend using Google Colab. And I put a link in the Slack to some information about that. Uh, for example, the new kind of cool thing now is that you can run Visual Studio Code and connect it right to Google Colab so you can use their GPUs and not have to worry about having GPUs on your computer. That's one of the things about this book. It is going to be deep learning um, material, so it's going to use in the later chapters, you're going to need to use GPUs to get the training done in a kind of reasonable period of time. But the good news is you can have a free Google Colab account and get that done. And the book is designed to work with that. Although they did say, I think, somewhere that later chapters might benefit from a paid account, but you won't need that, I don't think. Hopefully not. Hopefully that was reasonably clear. So the slides right here are just on my computer, but they're at a GitHub repo. Let me see if I can show you that real quick. This repo here, the link is in the chat in the Slack. And so what you do is the instructions are here, just follow the instructions, but in a real quick nutshell, I'm not expecting you to remember, and I don't necessarily think I'll have every step is the key thing is you fork this repo, you clone it to your desktop, create a branch, edit the slide for the particular chapter you're working on, and then do a PR and get it merged in. Basically, that's the high level view of it. If you know how to do all that, then you're fine. If you don't worry about that too. There's detailed instructions um, on the repo itself about how to do it. Using, if you're more familiar with R, you can use, even though this is not Python, this book club uses Python, you can use R to drive that part of it. That's what those instructions use, and that's perfectly works perfectly fine. They use this library, for example, if that's something you're familiar with. So if you miss a meeting, no problem. You can catch up with the video if you want to. You can watch us fumble through the slides for an hour and then catch up that way, or just read the chapter and you'll be fine too, most likely. So the pace, we're going to try to do one chapter a week. There is, let's see, how many chapters are there? 20 chapters, probably the 20 chapters not that big a deal, but so that's half a year we'll be doing this, which is fine. Maybe longer because sometimes one week we might have a chapter that's too big. Like, well, there's no way, for example, I don't know if this is true, but let's say, I don't know, chapter eight is not going to be a 1 week type thing. We can split it up and we can also do the opposite. If we have a chapter that's very quick, doesn't take much time to go through, or two of those, we have to have two, I guess. So we can try to combine them together into a single week. where was I? Here we go. Yeah, okay, okay to combine short slash chapters. So we'll meet every week except when there's a holiday. We'll coordinate this on the Slack channel as we usually do. And again, if there's a scheduled presenter not available, we will press on and meet anyway. I do encourage you to sign up for the future sessions. The sign-up sheet is on the Slack as well, Slack channel. So if you have any trouble with that, just feel free to ask anybody on Slack and they will help you out in the deeppy Slack channel. Every week, we'll try to identify some learning objectives. This is kind of optional, but they do recommend it just because if you have some objective in mind, you retain more. So the idea is, okay, what are we gonna try to get out of this week's session? So you'll see when I do chapter 1 here shortly, I'll have some objectives in mind for us to take away, which would be pretty easy because week 1 is just kind of like an overview. Okay, so this is a point where we can do like little introductions. So I'll start with me just so you kind of see what I'm talking about. I'm Ron Legere, as you can see there. I'm calling it from Scottsdale, Arizona. And as far as Python, I've been using that probably since it was invented. I think I've been using it for a long time, but I've also used other languages, R, recently used R, I've used Julia, and of course things like C, C++, Rust, whatever tool is needed, I'll try to learn it and use it, which is even easier nowadays, right? With AI helping you out with the translating from what you know into what you don't know. So, what was my introduction to Python? I don't know. I didn't write these questions. These are here. These are part of the repo. Um, I think it had to be back when I was trying to use Perl and I couldn't stand it, and I found Python as an alternative, and I've been using it ever since. As far as this book club, what I'm really looking forward to is learning, and some of it's going to be review for me, but a lot of it's going to be learning new techniques in deep learning, like how these different pieces fit together, especially these new pieces with the transformer architectures and language models, but also with things like image generation, all that. And I know that's later chapters, but I'm looking forward to seeing that. And I'm also looking forward to learning Keras library itself because I've used PyTorch before, and I've used some little bit of TensorFlow, mostly PyTorch, and the idea of Keras being kind of a universal layer, universal tool set on top of Keras, I'm sorry, top of PyTorch, TensorFlow, or JAX, and maybe others as time goes on, is a cool idea to me. And Keras is a mature framework, was originally just like for TensorFlow as well learned, but now it's compatible with all these, so I'm looking forward to that. That's kind of my introduction. Anybody else want to give a quick introduction? Wanyaki, do you want to go tell us a little bit about yourself? You don't have to follow these bullet points necessarily, but
I'll try to be guided by the bullet points. So my name is Ratsilisizwe Munyake, and I am calling from Cape Town, South Africa. So yeah, the time is literally 11:15 at
oh,
night.
okay.
How long have I been using Python? So I actually started learning Python in my first year. I had a computer science course there, and they were teaching it using Python. So this was like 2014. So then I was, yeah, didn't really do more comp sci after that. I think the only other computer science course I took, I learned Java. But then once I started working, I was using Python. However, since like 2022, I joined the research group at the University of Cape Town. They do mathematical modeling of infectious diseases and they use R. So I've just been using R the whole time. And yeah, I think I've covered my intro to Python. What am I looking forward to during pretty much everything? Since I said I've been using R, I haven't been using Python in a while, and also in my job, I don't do much machine learning, deep learning stuff, so I'm eager to learn more about that. Yeah, that's me.
Awesome. I
Um,
appreciate that. And Josh said he is not going to be able to, it's mainly going to be in listen mode today, which is fine. If you did want to type something, feel free to do so. But I think he said he's in child minding mode, so he won't be able to participate in that way. But feel free to jump in anytime,
awesome.
Josh, with questions, of course. All right, so that's kind of the introduction, end of the introduction. This is now I'm going to kind of give an example of how I would lead a chapter. I'm going to lead chapter 1, but again, you don't have to do it this way. You can do it any way you feel like it. Um, this is just using just to make it a little more concrete though. Maybe I should hang on a second. Like, Manjaki, have you ever been in one of these book clubs before?
Yes, I have been.
Okay, okay. Then you're familiar kind of with how the Quarto documents work. These slides are just basically made in Quarto, which you're probably familiar with, and then so it's pretty easy to make these. Just
yes, yes.
okay. I was going to show real quickly how it works in the editor, but I think people can figure it out. Okay, so this chapter is all about what is deep learning. So this, if you read this chapter, you already know that this chapter is mainly just kind of like an overview of what deep learning is and kind of where we are right now in the deep learning technology story. So the main objectives here are to kind of distinguish between what exactly is deep learning versus just machine learning and just versus AI. And then really at a big high overview, look at what are the core components, like the weights, which are the parameters of the model, the loss function, and the optimizer. And then discuss briefly the current state and expectations for AI coming forward from the point of view of the author of this of the book, right? That's kind of what he discussed in this chapter. And let me just say, just anytime we're doing these things, feel free to interrupt, jump in. Just don't, you're not being rude. This is the only way you're going to get the questions answered. So if things are unclear. It will probably won't have much in this chapter, but if it does, fine. But it's certainly in future chapters, things will become more muddied, I'm sure. So according to the book, there's three nested circles. The big circle, the big set is artificial intelligence. That's any kind of effort to automate intellectual tasks, including non-learning approaches, which I guess examples would be things like expert systems or logic programming, rule-based programming systems that try to automate intellectual tasks, flowcharts that try to, walk through choices that an agent could make, for example, or what other ones like there was Eliza, that was another old-fashioned AI thing that was done a long time ago. These are all code first, like you just figure out rules, you try to program in the rules to make the to automate the intellectual task, as it says here. Then the idea of ML is to turn that around, instead, just learn the rules directly from the data instead of programming them. And within that circle, there's a special kind of machine learning called the deep learning, which uses these successive layers of representation. And what that means will become hopefully a little bit clear as we go through these charts, but also in future chapters where we do this hands-on, so to speak. So again, this is the idea of classical programming versus ML. In the classical programming case, you have some data, you have some rules for transforming that data to get answers, and that so you go in that direction. Whereas in the ML case, you take the data and some answers to some of that data anyway, and you use that to try to infer what the rules could be. The computer will learn the rules. That's the basic idea of ML. The I also this is not in the book, but just something I wanted to throw out there because a lot of us come from this world of statistical inference rather than from the machine learning world. I just wanted to contrast that a bit. And one difference between machine learning and inference is normal statistical inference, as it were, is the goal, right? In a lot of our work, when we're doing inference, we have a model already. Like for example, we might have a disease model, or we might have I can't think of another example now, but we have some kind of scientific or um, causal model already in mind, and we want to know what the parameters are of that model. So we're trying to use inference, we're trying to get the parameters and the uncertainty. That's the main thing. What are the parameters of this model that are consistent with this data? And what's the uncertainty in them? Whereas in machine learning, it's we just want to be able to predict on new generalized predict on new data. Given all the data we have right now, what kind of patterns can we find from this to predict on new data? So prediction is the primary goal. And because of that, for inference, the models are something we usually given. We have maybe a few different models that might be plausible. They're usually theory-driven causal models. Whereas in ML, we will use very, very flexible models, models with many parameters, universal function approximators, often things like neural networks, Gaussian processes, random forests, this kind of thing are kind of the main tools of ML. Of course, ML can also be used linear regression as a tool. There's a kind of a spectrum here between these two things. They're not two clear-cut categories, but they are kind of two extremes of categories, as it were. And for machine learning, the kind of the sweet spot of the data regime is large amounts of data, and you make very few assumptions about the data. Whereas in inference, we're generally working the where we don't have a lot of data, and we have to make some strong assumptions to get some results out of our data. So that's kind of my take on what the difference is between machine learning and statistical inference. So again, this is not in the book. This is kind of my opinion on that. So if you have a disagreement with that, feel free to jump in, but that's how I see it. So next, but after that digression, for me, the book continues on with talking about the three main ingredients of ML. So the main ingredients are the input data. Like for example, you might have images, you could have text, you could have audio samples, you could have tabulated data, stock data, whatever it is, your input data points. And then for that data, you also have some labels, labeled data, example outputs, it calls it here. So for example, you could have a bunch of pictures of animals and the labels could be what kind of animal it is. And you're going to train a machine learning model to learn those labels for new images that aren't labeled, basically. That's the idea. And then finally, the third ingredient you need is some kind of measure of success, some kind of what they call a loss function that tells you, was that the right label? Was that the right transcription? Was that the right category of that data? Or whatever the case may be. That's the main three ingredients. And that third ingredient is crucial because that's what gives the feedback to drive learning. Now, uh, just a little digression into what a representation is. Uh, they use the term representation in this book to mean some basically just a different way to look at and code the data. That makes some task easier. And so one way to look at machine learning as a tool for finding useful representations, right? And I give an example here where there's this raw data where if X and Y and the light blue and the black are two different categories we're trying to learn. In this coordinate, it's actually somewhat difficult to do, but if we change coordinates to this coordinate, where we rotate things, then it becomes much easier. Separating black and white just becomes a simple rule. X is greater than zero. And so the idea of machine learning can be thought of this way is what we try to do in a machine learning system is to find a useful transformation of the data that changes the coordinates, as it were, to a more meaningful representation. And this will come up again and again in this course because that's what it comes down to is finding these transformations to better represent the input data. So in deep learning, this is this idea of the successive layers of representation. Instead of just one representation, we generate a one high-level representation. This is the example of the MNIST data set, which I think we'll probably look at in the next chapter. It's the hello world, as it were, of the machine learning world, and it's the idea of recognizing these handwritten digits. So the original input is this image of a four, and the output over here is what is the digit? What's the prediction? And here it's predicting a four, which is good. That means it's working. And it does that by using these different layers of representation. So it learns somehow this layer of representation, it learns another higher level representation, and finally there's this very high level representation that turns it into the simplest, the final real final representation, which is the output that's a four. And so that's what deep learning actually is successive layers of representations. And big deep learning frameworks like the large language models have hundreds or really maybe thousands of layers in all those layers, all those layers are learned automatically. And the book calls this a multi-stage information distillation process, which is quite a mouthful, but I like it. So next part of the chapter breaks it down into like three figures to how this works. And I've kind of turned this is all these figures, by the way, are from the book. It's not mine. These are all in the book. So this is a kind of a two-layered deep learning uh, system here. We have some input X. We got first transformation, a second transformation, and then finally we have predictions coming out at the bottom. And the goal in each layer is characterized by some parameters, which in the machine learning world or in the deep learning world are called weights because that's what they're called. And biases are in there too, but they're called the weights. And each layer has its own weights. And the goal is to find the right values for these weights, is set all these different numbers to make this transformation work. So what we do is we have an input and we also have an actual true label for that input. So we know what that input is for that particular set. In the training data, we pass it through the prediction. Now, initially, the weights are just random, and we pass through the input and get the prediction out. And we have the true target. We compare them through some loss function. Don't worry about the details of that right now, but there'll be some loss function that will give us a score, how well it did. And that's the second step, right? Let's see how well we did. And the third component of this thing is now take that loss and use it to improve the weights. Essentially, we want to move the weights in a direction so that we decrease this loss. And the central algorithm for doing that in deep learning is backpropagation, but that's just a detail. The idea is simply to use this loss to change the weights to get the predictions closer to the targets. And the hope is that if we've made this structure correctly, it'll learn useful representations that can generalize to unseen targets. And that's kind of the challenge, as we'll see. So that's kind of as technical as we're going to get this chapter, but just take a step back now and just ask, like, what is it that makes deep learning so different than other types of learning? One of them is this idea of that he talks a lot about in the book is automated feature engineering. Often in machine learning, like for example, you were using, well, I guess I'm having trouble thinking of a good example, but often you have to like do some hand. Well, you know this, right? You know, often when you take your data, you have to do some feature crafting on it. You have to say, okay, what kind of things in this data are going to make the most sense for me, especially if you're using like a linear model of some kind. And you spend a lot of time doing that. Well, instead, here the deep learning will automatically find that the best possible features, or not the best, but good set of features for your prediction task. Another thing that makes deep learning so powerful is this ability to most of these operations that are used in these deep learning models, these models are based on matrix multiplication for the most part. And so you can use GPUs to accelerate that. And also it's because we can use batching, we can accelerate it by doing things in parallel as well. So it's got a lot of scalability. And that's one of the things that's really led to the explosion in deep learning in the last 10 years, I would say, but maybe more years. And again, these models are very flexible, they can be reused, and you can also you can do online learning. That's where you can take a model you've already trained, and you learn. You have some more examples. You can continue to train or fine tune. Sometimes they call it the model online, so it can continue to get better when you get more data. That's a point that he made. I don't think that's as important, but maybe it is. Another key thing is really sparked a lot of deep learning interest is, of course, is generative AI. One of the reasons why generative AI has been so powerful is that you know what I was saying before is like you have data and then you need labels. Well, often getting that labels is hard to do. If I'm doing image recognition, for example, I have a whole bunch of pictures of animals. Now I need to have somebody go through and label some of those so I can use them as examples to train my deep learning model. Whereas with these generative AI models, they're self-supervised learning. For example, with language models, the the thing you're trying to label is in the data. You're just trying to pick the next word. Well, it's in the data what the next word is. You just don't tell the model, and it has to figure out what the next word should be. Or in the case of image reconstruction, you take an image, you make it noisy, and you train it to reconstruct that image. But you have the label; it is the image itself. So that's led to this explosion of things like ChatGPT, Gemini, Midjourney. All these big models are able to be trained on this massive unlabeled data that we have. And he calls these models fuzzy databases of human knowledge, which is kind of true. Like if you download a local large language model on your computer, you can ask it things and it will often know things. It's not able to search the web. It's just a local model on your computer with no access. It's just in the weights. Of course, it also will hallucinate things that aren't true. So you have to be aware of that as well. And so he makes this like list of all these great things that deep learning has achieved. Of course, we just talked about the chatbots and all that kind of stuff. Well, I don't know if you're familiar, but like GitHub Copilot, Claude Code, all these things just are getting better and better by leaps and bounds by month. It's pretty amazing. Video generation, image generation, some of these things are very powerful and somewhat scary in what they can do. Uh, Image classification, this kind of thing, of course, works really well. Nowadays you can talk to anybody and with almost any language with your iPhone. Like it was almost like Star Trek, not quite at the Star Trek level communicator thing, but it's pretty amazing. You can translate languages pretty quickly. And I'm here in Phoenix, and I see these Waymo self-driving cars driving around all the time now. Every day I see one or two of these things. It's just bizarre to me. Cars with nobody in them, just driving around. And then there's like these reinforcement learning has made some great strides as well, using deep reinforcement learning to master things like the game of Go and poker, things that people thought maybe a few years ago would be impossible to do, or at least pretty far from now that somebody would write a program that could play Go as better than any human could do. But given all that, we still have to beware of the hype on this thing. There's some predictions that were made for the year 2023 that didn't pan out. People were saying, oh, no one's going to ever need to work anymore. We're going to see 10 to 100 times productivity gains, mass unemployment due to these large language models. It's just not happening, which is good, but people are worried about that. Just got to be aware of the hype. And the reality is there is a lot going on with AI, generative AI in particular, lots of revenue being generated. I think OpenAI just released numbers that they were generating 20 billion just themselves, $20 billion of revenue last year. Of course, they spent a lot more than that, so they're not profitable. I don't know how much they spent, but they're not profitable still, but they're generating revenue. And there's a lot of, and then really the investment in AI is still huge. People are investing a lot more money than they're getting in revenue as well. So it's there is a lot of hype, but just be aware of it. And there's also a lot of talk about we're very close to artificial general intelligence. That's like, uh, the computer that's like a human, passing the Turing test and beyond. And the book makes the case that really this kind of artificial intelligence is cognitive automation. Um, it's not, it's just the computer's only handling what it's been trained for. It's just an automaton still. Whereas true intelligence requires something he called cognitive autonomy, being able to face the unknown, adapting and learning from it. So he thinks right now that AI is like a cartoon character. This is quote, think of it this way. AI is like a cartoon character, while intelligence is like a living being. A cartoon, no matter how realistic, can only act out the scenes it was drawn for. So he's kind of making a case that we're not really on the road right now to true artificial general intelligence by any means at all. He says, what else he says? He says, no matter how complicated you make a clock, you're not going to make a time machine. Something like that. It's another little example he gave in the book. And I think, I mean, in my opinion, he's probably right. I don't think we're really going down the right road for that, but we'll see. It's hard to say nowadays. Things are always surprising. He also talks about this kind of history of AI winters. In the 60s, there's a lot of hype about symbolic AI, and people really thought even then that hey, we're like super close to artificial intelligence. And there's a bunch of philosophical discussions back then. Well, what is artificial intelligence and all that? Um, that There's a lot of money spent, and then in the 70s, everybody stepped away from that. It was going nowhere as a dead end. In the 1980s, there was a big boom in expert systems. That's around the time like object-oriented programming also became big, and it was kind of related to that. But then in the 90s, also nothing really came of that. Those systems were turned to be too unwieldy and clunky. And now we're in the next boon, the generative AI boon, AGI soon. But will there be a crash? The author thinks it's unlikely to be like a complete crash, but he does think that, I mean, I guess it's an easy thing to predict. I guess some air will come out, but it seems like there's got to be some air come out. It's pretty overinflated, it seems to me. But then again, you don't know, there could be a huge breakthrough tomorrow. Check your archive. See, the kind of last thing he talks about here is this long-term promise. So the second edition of the book he wrote he said in the future AI will be your assistant. It'll help educate your kids. It'll watch over your health. It'll be your interface to an increasingly complex world. So he did kind of predict that, and that's well, you know how that turned out. It's mostly the case, right? A lot of those things are there. But he also says, well, maybe we're still kind of in the internet of 1995 when there was Google and Yahoo and all these things are competing and no one really knew where things were going to go. So, and already thinking it's kind of funny thinking of Google and Yahoo when they came out, they didn't have any ads on it. And guess what? ChatGPT has decided just yesterday they're going to start introducing ads into the free and the what they call the Go level of ChatGPT. So ads are coming your way on your chatbot. So that's basically my overview of the chapter. The next chapter, chapter two, hopefully somebody can pick up, and we will talk about more examples. Well, we actually start doing some coding in that case. I think we're just going to be looking at like using NumPy, kind of like just to get a feel for how these deep learning systems work without using the frameworks at first, if I remember correctly from my quick perusal of it. I'm not sure. I did have some questions here. I don't know if anyone wants to pick up any of these, talk about this. Um, for example, anybody, I guess just you and me, Onyaki. So do you want to talk about any of these things? Like what's one thing that deep learning should be applied to, or are we really in a hype cycle? What's your opinion on that? Or, is self-supervised learning really different, fundamentally different from supervised learning? Any of these things strike your interest? or anything else you want to talk about about the chapter.
Um, to be honest, I'm not too informed to discuss, say, number one. Also number two, I don't think I've done enough thinking, but maybe with maybe I can open my can. With three, are we in another hype cycle? I feel like this has been coming up a lot, especially like in financial news. So I'm not actually too sure. One thing that I suppose maybe is different with if we look back with like the internet crash, these AI companies are kind of making money. Yes, they're investing a lot more than they are making, but the key thing is that they are making money. So maybe that's what's different. I don't know if it's different enough to not
That's a good
so that you
point.
don't get
Yeah.
like a blow up. But yeah, I suppose that's the one thing that's different. What I am curious to know though is one, but I don't know if you have insights on that. The thing of is self-supervised learning fundamentally different from supervised?
Well, what I was trying to get at there is that if in self-supervised learning, you the labels are in the data. But also that's kind of true.
Hmm.
I don't know the answer to this question. These are just things I was thinking about. So I don't think that I know this. None of these have right answers. These are just things I was thinking about. Uh, but I was trying to think about like, self-supervised, they call it self-supervised versus, um, oh wait, I said versus, I meant to say versus unsupervised actually, is what I was kind of thinking of. Uh,
Unsupervised. I see. I
yeah.
see.
But actually now that I think of it, this is actually a good question too. So is it fundamentally different than supervised learning is maybe a better question because in supervised learning, the difference, I think, is that you need someone to label the data almost every case, right? You can't, the data doesn't come pre-labeled like it does in self-supervised.
Yeah, you need the example and the output. Yeah.
Right. So in the self-supervised case, almost always it's the case that the example is either like the next token that's already there in the data, or it's the image itself that you're trying to generate. Um, Whereas in supervised learning, you really need somebody to generate the label for you. Like, what is this, a cat? Is this a number four? It has to be in there in the data already. So I think so I think it is fundamentally different in that sense. But in terms of unsupervised learning, where it's like things like clustering and all that, I guess that's also fundamentally different because in that case, we're just trying to find, well, no, it's kind of similar. We're trying to find patterns in the data, right? That's kind of the goal, find
Yes,
patterns in the
yes.
data. So I don't know. I don't think there's a clean answer there, but I mean, they're different. Are they fundamentally different? That's the question. I don't know, but I'm not exactly sure what I
No,
was thinking. And number
I hear.
number two, I would say there are some things that deep learning shouldn't be applied to. That's things where that's like I was saying before, where really you need to use stronger assumptions. You need to have some kind of what do they call it, inductive biases in your problem, or to try to, you have like a model, like a causal model. Like for example, you wouldn't. Uh, I was trying to think about a good example. There's like if you wanted to have, let's say, you had cameras around a building and you wanted to know if it was raining or not, right? You could train a model on pictures of when it's raining and when it's not raining. Now, the model would use the presence of umbrellas in the images to help it predict when it's raining.
It's
Because
fine.
when you see
Yes.
umbrellas, it's probably because it's raining. There's a highly correlated. But that's not a causal model because we know umbrellas don't cause rain, right? So it's like you shouldn't use deep learning for things where you're looking for causal relationships. So you wouldn't conclude from that, hey, we want it to rain. Well, when there's lots of umbrellas, it rains. So get a bunch of people out there with umbrellas. We'll get some rain. That won't work, right? And you may laugh at that, but it's interesting that people use deep learning in their businesses and they do stuff like that where they don't realize that they're trying to make something happen with their business, but they're really just putting up umbrellas, expecting for rain.
That is a very, very good example.
So that's something I was thinking about. Anyway, it's a fun. I think it's gonna be a fun book. I actually do have the print version of it here, and it's a lot in there. The print version is kind of nice because it has like really nice pictures you can look at when you're sitting on your couch and look at the
Oh,
nice,
no.
nice
I mean,
diagrams.
just the first chapter alone, I genuinely enjoyed, and I got so much from it. Um, yeah, and this idea of like literally, we're just looking for different representations. That was
Yes.
like quite eye-opening for me.
Yeah, and that's kind of the idea is to try to transform these digits into different representations. It's really clear, like when you think about or not clear, but it really helps to understand things like how ChatGPT works too. It's doing the same thing. It's taking the tokens or the words, but tokens are like subwords really, but and transforming them, it's in the name, transformer, transforming them into different representations of those words, where
Yes, yes.
the representations now include information about what other words were near it, whether they're important words were near it, what kind of word it is. You know, the word orange, is it a fruit? Is it the color? That'll be in the representation. It'll be much richer representation of the word than the token orange. And and that's why it's called a transformer architecture, because it transforms the representation
Makes
through the
sense.
whole
Makes
architecture
sense.
until finally it transforms it into a really good representation of what the next word should be. And it makes
Yes,
that
yes,
prediction.
yes.
Yeah, it's pretty cool.
No, definitely. I'm definitely looking forward to it.
Cool. And let me just hold on, stop sharing here. And so what you want to do is if you're on the Slack, there's the bookmarks at the top of the Slack channel tell you like the little thing says sign up and pick meeting time. Maybe I can share that too. Hang on a minute. Let me go back. Please wait. No waiting. Oh, I picked the wrong thing. That's the wrong thing to click. Uh, well, where is we don't have that bookmark on here? I gotta get him to put the bookmark on there. Is it pinned? Oh, here we go. Hang on 1 minute. So there's a pinned message I want to put this in Slack again though. Here we go. Um, just share
Ah,
my
yes, I just
screen.
see. Oh, the spreadsheet. I see, I see.
Yeah. So I'm just gonna share that so you can see what it looks like. So there's the spreadsheet looks like. Put this back over here so it's easier for you to. Oh no, you can't see this, but just see those are. So I put this link in here. I got to share a different thing. Should have just shared the whole screen. It'd be easier. There you go. Now can you see the spreadsheet? No.
No, I can only see you.
There we go.
Now I can. Now I can.
This is what the spreadsheet looks like. So what you want to do is, pick a chapter you think you'd be interested in. Again, it's the best way to learn this material. These chapters only get harder, so I definitely recommend jumping in early, like with chapter two, and which is probably a pretty straightforward chapter on using NumPy mostly to implement some of these neural network things and try to understand the core components of what are in these neural networks uh, that are part of deep learning. And what are neural networks? It's all in there. So if that's, for example, is a good one to sign for. But you don't have to do anything today. I'm just saying that anybody listening, I recommend that. And
Yes,
uh,
yes,
and
yes.
then yeah, and I'll get John hopefully to pin that. Yeah.
Yeah,
Any
no,
other?
I am gonna take a chapter because I remember in the other book club I was in, like preparing for the chapter, I learned quite a lot.
Exactly. It's
It
yeah,
really
exactly.
helps.
It's easy to it's so easy to read through a chapter and go, yeah, yeah, I get it, and then go off and do your other thing. Whereas you try to prepare for it, you're like, oh wait, I didn't get it after all. Let me go back and dig into
Exactly. Now it's a different story. Yeah,
that.
yeah.
You got
When you
that.
are going to have to explain it, then you really, really make sure you get
Yeah,
it.
excellent. Did you have any other observations or questions, or Josh, do you have anything? I think I closed the chat window though.
Good on my side. I'm not sure if George has said anything.
Nope, he hasn't. So okay, well, I'm gonna